In maths, we often use letters instead to represent numbers. And why do we do that, and what does it mean? Well, if we have a plus a plus a plus a, what does that mean in terms of a number? Well, if there's no number in front of the a, it actually just means there's a 1 in front. So we have, imagine that this is actually not a's that we're adding, it's apples. Okay, and we're just, instead of writing the whole word apple, we're just writing a. So if we have one apple and we add another apple to it and another apple to it and another apple to it, how many apples will we have? Well, we'll have 4, but we're not writing the whole word for apple, we're just writing a. So 1a plus 1a plus 1a plus 1a is the same as 1 plus 1 plus 1 plus 1, 4. 4 what? 4 a's. That's our answer. The reason that this is useful is we can actually change what we say a is. One time around I could say a equals 2. What is the answer to 1 times 2 plus 1 times 2 plus 1 times 2 plus 1 times 2? Well, I have to add 2 up 4 times here. Whereas if I kept it in its simplest form, which is 4 times 2, I've simplified 1a plus 1a plus 1a plus 1a to 4a. It's much easier for me to say, okay, if a is 2, then the answer to this is 4 times 2, which is 8. I can then say, but a isn't 2 anymore. I've now decided that a is 16. So a is now 16. What's the solution to my question? Well, 4 times 16, double 16 is 32, so 4 times 16 is 64. So I can put any single number in there. One time a might be 16, another time it might be 1,000, another time it can be 1,000,000. So it's very useful in maths to use letters instead of numbers. It allows us to change the letter with a number at any time that we want to do. So what do I do then when if I've got 1.5a plus 2.5a? Well, I know that I'm adding in a's. And then I think, well, what's 1.5 plus 2.5? Well, I know that that's 4. So my answer to 1.5a plus 2.5a is 4a. Then it doesn't matter if I say a is 50 or a is 1,000. It's much easier for me to work it out as 4 times whatever number I say a is than it is to work out 1.5 times it and then add 2.5 times it. Okay, now we've not got A. It doesn't matter which letter of the alphabet we use. We often use A, B, C or X, Y, Z. They're the most common letters to use. If I've got 2x minus x plus 4, well, I just look at the numbers. I know that I'm counting in x's, so I put that in my answer. Then I think, what's 2 minus 1? Because there's a 1 in front of that x. 2 minus 1 is plus 1. And 1 plus 4 is 5. So I just look at all the numbers that are in front of the x's and add them or subtract them as the numbers tell me to do. 2 minus 1 is 1, 1 plus 4 is 5, so the answer is 5x. What do I do when I've got a mixture then? Well, I have to first look at all the a terms and put them first, and then I have to plus or minus how many b terms we have. So I can't add apples and bananas. There's no such fruit as an apple banana. So I add different letters by themselves. 3a minus a, well, 3 minus 1 is 2, so it gives me the answer 2a. 2b plus b, well, 2 plus 1 is 3, and I've got everything is positive, this is positive, and this is positive, so it's going to be 2a plus 3b. So that's the most simple form I can write, and it's much easier to have it this way than it is to have it as a long string. So the first thing we do with algebra expressions is we get away these long strings of very similar terms and make it so that the terms are as few terms as possible. But we can't turn a new fruit and make an apple banana. We have to keep apples for themselves and bananas for themselves, or x's for themselves and y's for themselves. We have to keep them separate. So this is some of the basic. Well, what do we do then when we're multiplying? Because multiplying is totally different. What is a times a? Well, if we think of, let's say that a is 3. 3 times 3, we know, equals 9. Is there another way we can write it in terms of maths? Yes, there is. Whenever we have two numbers multiplied by each other, the way that we write it in maths is we have the number 3 and we a squared number up there. It means to the power of. In the same way that we use that in area, we're multiplying centimetre in the length by centimetre in the breadth, and we're saying that that is the units centimetre squared. That's what the square means. It means we're multiplying the number centimetre by itself, centimetre squared. So a multiplied by a in maths would be written like this, a squared. B times 2b, well, there's actually a 1 in front of the b. 1 times 2 is 2, but b times b is b squared. B times 3b, well, let's change it into 2b times 3b. 2 times 3 is 6, but b times b is b squared. And this is where it's different. The next one is where it's different. What if we have 2a times 3b? Now, I told you that when we were adding, we can't turn a fruit into an apple banana. The difference is, this isn't apple bananas, this is A and B. We can actually multiply A times B. We do it the same way. 2 times 3 is 6, but A times B is actually written as AB. So when we've got different letters in multiply, we are actually just put them after one another. So 2a times 3b is the same as 2 3s are 6, a times b is written in maths as ab. We always write it like that. It actually means the same as this. We could actually write ba. 6ba is the same as 6ab, but we always put the first letter of the alphabet first. So the way that we write it in maths is we would always put whichever letter of the alphabet came first as our first letter after the number. And that's just standard. It's something you'll practice as you do it more and more. What then if we had something like this? 1.5 p times 2q. Well, we'd say that 1.5 times 2 is 3. P times q is pq. So that's, how easy algebra really is. It's just manipulating the numbers. Then I can say, oh, P now equals 3 and Q equals 4. What is 3 times PQ? 3 times PQ. When P equals 3, well, P now equals 3, so we'd say 3 times Q, which is 4. 3 4s are 12, 12 3s are 36. So we get the answer very quickly by putting them in that terms, instead of first having to work out what 1.5 times of P was and then multiplying it by 2 lots of Q. So this is an easier way of doing it. Okay.